Hi, I am Marc Weiss, and some of you may know me as Weiss on Twitter, and today I am going to present the importance of auditors at the core of the DeFi protocol. So I'm currently an independent security researcher and a private auditor at Ambit Finance. I do private auditor. I'm also a lead senior Watson in Sherlock DeFi, and I'm a security auditor at Paladin Security. So as my talk involves how an auditor researcher could help in all the stages of a DeFi protocol, I will first explain those stages and how an auditor could be helpful in them. The first one is development. It's the stage that goes from the ideation, the design of the code base, and the architectural decisions. Normally researchers have audited or gone through hundreds of code bases, and they know the best architectural decisions and how to better design each type of code base. For instance, if you are doing a borrowing and lending protocol where you want to use a dynamic or a fixed interest model, whether you want to use upgradable or unupgradable contracts, which type of them you want to use, whether you want to use proxy pattern, TPP or UUPS, and if it's non-upgradable, whether you want to use a registry-based architecture. That goes hand by hand with the testing suite, so auditors could help similarly in both of them. The third stage would be the audit. The audit would happen once the protocol has already the contracts ready for mainnet. This would be most once the testing suite has a range of more or less 100% coverage, whether the protocol already also used fuzzing, whether it used the internal Foundry fuzzing or Echidna or whatever tooling. And for independent researchers, an audit would consist in a security review that would would just give the protocol and give the report to them internally. Once this report is done, the protocol would go to mainnet, or even they would set up a bounty with any of the bounty platforms. And in mainnet, the researchers are very useful because they have already a lot of experience there, and there are so many things that can go wrong that their experience could be very helpful. To complement the stages, we would have the root causes of hacks in the DeFi protocol. I would highlight 6, and the first one would be lack of knowledge. Lack of knowledge would be anything that has to do with like reentrancies, under overflows, or even not understanding some EIPs, like the EIP 150, that it's basically that you would forward 63 out of 64 of the remaining gas to external calls, or other APEs like 2929, where you would just the gas that's spent on opcodes like call, it changes depending whether the call has value or not. The second root cause I would highlight, it's like external vectors. External vectors would be like private key leakages or something external to the auditors itself. Point number 3 would be contract maintenance. Depending whether you're having, for instance, an upgradable code base or non-upgradable, you would have to upgrade the contracts, point to the right implementations. If you have a registry-based architecture, you have to deploy new contracts and just set up the new state variables. Number 4 would be architectural errors. Architectural errors would englobe whether you are handling correctly external contracts, whether you are having, for instance, fallback oracles if you need them, anything that has to do, as I said before, with interest rates models, if it's fixed or dynamic for lending borrowing protocols, anything like that type. Number 5, we have logical errors. Logical errors would be anything that has to do specifically for that code base that the developers developed. For instance, some state that has that should not be getting at, some invariant that you broke, or the code base just can get to a denial of service state that you cannot recover from. And 6th and last would be deployment scripts, which is very underlooked by a lot of protocols. And actually, there are a lot of errors there, which normal audit firms, neither independent researchers do review. So I prepared an example for them. So this is a contract where it has 2 permissions, the operator and the owner, owner being the root permission. And a correct deployment script for this contract would be basically that you would call the constructor and just set the owner address, and after you would call set operator and set the operator address. As you can see in this contract, there is only one. There are more functions, but highlighting one function, withdraw funds, that it should be only going through with the operator address, as you see on the last require, that it checks that the signature recovery it's equal to the operator. So the operator should be the only one to be able to withdraw the funds. In a faulty deployment script, for instance, the developers would just forget to call set operator because it's not on the constructor, and then would cause, if this is underlooked and this is in mainnet and the funds are just entering the contract, anybody would just be able to steal all the funds because, as you know, EC recover with a faulty signature would return 0, and it would pass the require signer is equal to operator. So to complement all the said beforehand, here we have the benefits of having auditors and researchers in your DeFi protocol. This would complement everything like we spoke, the root hacks and the stages. So firstly, it's the benefits in war rooms. The benefits in war rooms, as we know, a lot of researchers have been, mostly experienced researchers have been in war rooms before. War rooms generally happen once a protocol gets exploited in mainnet. That now we know that happens pretty much every week. So they are quite common, and there's periods of time where it's critical to act fast, and basically it's just you are in a lot of stress, and auditors and researchers are usually on that stress, and they have experience on this, so it would be a critical point where auditors would be able to help protocols here. Secondly would be breakdowns of boundary report that goes together with proof of concept building. Pretty much any researcher, auditor builds proof of concepts at least weekly. And it's very critical for protocols to actually be able to do this proof of concepts fast in case they are exploited, as it goes together a bit with the expertise in war rooms. And same thing with breaking down bug bounty reports. We know that bug bounty reports are not always the best quality. It depends on the experience of the hunters. And there are a lot of times that you can say whether a bug is actually valid or not by just looking at the report, but it's not always that case. There are reports that actually come with very low quality, there are findings that actually come with a very low quality report, that they are underlooked and they're probably not very good to understand by the protocol. So as auditors really have been through a lot of reports, they could just help breaking those down and implementing the fixes. Then you have much cheaper than paying a critical bounty. Researchers and auditors are not cheap neither, but would you rather spend $500,000 in a critical bounty or just hire 2 researchers that they probably are not going to cost that money and you might be able to save it? Lastly, security-based approach on designing protocols. This goes a bit with the beforehand design explained. It is clear that a lot of bugs actually are in the code bases because they are not designed correctly. It's critical that the code base have a secure mindset when designing them, and auditors do have it, so they could advise in the best way to those protocols. So thank you. I am Marc. Any inquiries that you have about private auditing, anything about the presentation itself, anything you want to ask me, you have my email, my Twitter. So yeah, I'm open to answer questions.